Okay, so we're going to start off with a review of factoring from Algebra 1. And so here's your definition for factoring, where we're just saying if I ask you to factor something, we're asking you to break it up into, breaking up one expression into many parts. It could be 2, it could be 3 or 4, and those parts should multiply and give you the original expression back. So here's a simple example, just using numbers, of what we mean by factoring. If I said take the number, let's say for example 12, okay, you could factor 12 into 6 and 2. And that's factoring. This is what factoring is. I could further break down this 6 into a 3 and 2, and so another factored version, I could say 3 times 2 times 2 is equal to 12, and so this is the factored version of 12. So we're just trying to break up some expression, in this case 12. I could break it up into 3 times 2 times 2, I could break it up into 6 times 2 is 12, I could break it up into 3 times 4. However you're going to break it down, that's what we mean by factoring. So typically when we're doing algebraic factoring, we're going to continue to factor it until we can't factor anymore, which would be this version right here, right? These are all prime numbers, they don't break down anymore. So that's what we're going to be looking at. So we're going to kind of just do a quick tour of all of the types of factoring that you should have learned in Algebra 1 that we will be using in geometry. So here's your first simple example. So this is the kind of the standard one that's used a lot. This is a quadratic because of the squared, and it is a trinomial because it has 3 parts. Okay? And so we're going to break this up into 2 expressions. So the first one, or the way that we're going to do this, is we're going to say if you can find me numbers that add to the middle number and multiply to the end number, okay, ULT, multiply, okay, that you're going to be able to set up an expression like this. So we're going to set up 2 parentheses. This x squared, remember x squared means x times x, so I'm going to take the 2 x's that are in x squared and put them in each of the parentheses, and then I'm going to look for a pair of numbers that multiplies to 12. Well, if I go through the list of things that multiplies to 12, my choices are 1 and 12, 2 and 6, 3 and 4, and this is it. This is all the pairs of numbers that multiply and give me 12. If you take a look at this last example does add up to 7. 3 plus 4 is 7. So I'm going to say this is positive 3 and this is positive 4. And so I'm claiming x plus 3 and x plus 4 is the factored version of x squared plus 7x plus 12. So let's just do a quick check on that. If I were to multiply this back together, which is what we did here, we said 12 is 3 times 2 times 2, because if you do 3 times 2 you get 6 times 2 you get 12. Those parts multiply and give you 12 back. So these parts should multiply and give me x squared plus 7x plus 12 when I multiply them out. So if I multiply this out, it's going to be x squared, right, when I do this, okay, plus 4x, okay, and then I'm going to go to the other part of that expression, right? So I did x into both of these, so I have to do 3 into both of these. So I'm going to say 3 times x, well that's 3x, 3 times 4, well that's 12. Well, the 4x and the 3x, they do turn into a 7x, and so this is x squared plus, for some reason my pluses keep looking like multiplication, plus 7x plus 12. So this works, right? I broke it up into 2 expressions. Those 2 expressions, when I FOIL it back out, when I multiply, do give me x squared plus 7x plus 12. Okay? So here's your second example. So this rule works when I have when I have 3 terms, right? X squared, 7x, and 12 are my 3 terms. We call that a trinomial. So when I have a trinomial, and when it's a quadratic. So there's some exceptions to this. It can work for other types of expressions, but generally for us we're going to say quadratic. Okay. So what happens if, for example, it only has 2 terms? What if it's a binomial? So if it's only a binomial, we really only have one case that we can work with, and that is if the binomial is a difference, right? So this word difference means subtraction. So if there's subtraction between 2 squares, so 2 things that can be written as a number squared. And so let's just go right down to an example and you'll see what I mean. Okay, so if I take this x squared minus 81, well, the first part of this is already something squared. So I'm going to say that this is x squared. The 81 doesn't look like something squared, but I can rewrite it. 81 is really 9 squared. It's 9 times 9. And so I can write 81 as 9 squared. So this is a binomial expression that I can write as the subtraction of 2 things that are being squared. Even though it wasn't originally written like that, I can rewrite it in that form. When that happens, I can factor this, and this is the only case where I can factor. So what this rule up here says is whatever you squared first, that's going to go up front. Well, it looks like I squared x, so I'm going to take both of these parentheses, and I'm going to put an x in the front of them. Because that's what this rule says to do. It says whatever you squared at the beginning goes in the front of both of your parentheses. It looks like the back number goes into the back of both parentheses, so the 9 is going to go into both of these. And it looks like the rule says make sure that one of your parentheses has a plus sign, one of your parentheses has a minus sign. And that kind of makes sense because to get a negative 81 when I do multiplication, the signs have to be different. So it makes sense that I need a positive 9 and a negative 9. Okay? So let's look at the second example because it's a little bit different. So if I look at the second example, I'm going to look at it and say, okay, well, I need to write this whole thing as something squared. So 16 is 4 times 4. And x squared is obviously x times x. So if I do 4x times 4x, I'm going to get 16x squared. And then this can be written as 49 is 7 squared. And so I'm going to do the same thing. Whatever I squared, which in this case was just 4x, that whole thing, is going to go up front of both expressions. And the 7 is going to go in the back of both expressions. The rule says I need a plus and a minus. That's the only way that I will get a negative 49. Okay? So again, this whole idea is when the number of terms in my expression that I'm factoring is different, in this case it's got 2 terms instead of 3 terms, that means that I need a different way of factoring in. So my different way of factoring in this case is for a difference of 2 perfect squares. Okay? So let's move on and see what else we have. Okay, so now let's take a look at this. Getting a little bit more complicated. So with every expression, this is where we're going to end. Okay, oh no, I'm sorry, we have one more. With every type of polynomial, so this is in this case a trinomial, but you know I'm kind of stuck here because I see a 3 as an exponent at the beginning of it. Our trinomial example way back here had a 2, right? An exponent of 2 is a quadratic. So this rule doesn't really work, and so now we're kind of saying, okay, well, how do I handle stuff like this? So with this, we have what's called factoring out a monomial, and this is something that works for any expression. You can always try it at the beginning before you get started. So let's see if we can do that. Factoring out a monomial means that we're going to say if there's anything that is in common between all of the numbers, the 3, the 12, and the 15, if there is a common factor, we can remove that common factor. And in this case, 3, 12, and 15 all have a 3 in them. So I'm just going to write that down. Okay. I can also look at the variables and say if there are any variables that all of the expressions have, I can remove that as well. So in this case, I see 3 x's, I see 2 x's, and I see 1 x. So they have 1 x in common. Right? I can bring out 1x, so I'm just going to write x. I can't bring out 3 x's because this last example, this last 15x, doesn't have 3 x's to take. It only has 1. So even though, yeah, they have 3 x's on the first one, I don't have 3 x's in all of them, so the best I can do is remove that 1. Right? So now I'm going to go to this and I'm going to say, well, what's left over? Well, I removed the 3, and I removed 1 of the x's, which means I have 2 x's left, so I'm going to write x squared. Okay? I have to figure out how do I multiply 3 times something to get a 12. Well, it looks like I would have to put a 4 here. And again, this has 2 x's. I pulled 1 of them away, which means there's 1 left. And then how do I turn 3 into the 15? Well, I'd have to do 3 times 5. So I'm going to put a 5 here. And I only had 1 x. I removed that one. It's on the outside now, so I'm going to close that up like that. So that's the factoring out a monomial step of this. We got rid of the common 3x that was a factor of all 3 terms of this trinomial. But we got to be careful, okay? There's always the possibility that after I remove this, that what's left over, in this case x squared minus 4x plus 5, maybe that will work for something else. Maybe I'll be able to factor that again, because this x squared minus 4x plus 5 looks a whole lot like this one that we started with. So maybe I can use this rule about factoring quadratic trinomials on my new expression x squared minus 4x plus 5. So let's take a look and figure out if we can do that. If I look at the factors of 5, my options are really just 5 times 1. Well, guess what? 5 times 1 to get a positive 5 adds up to 6. That 6 is not negative 4, which means that it's not going to factor, right? If this was, for example, a negative 5, then I could, but that's not the case here. So I'm actually going to stop here. I'm going to say I tried to factor it. It didn't work. so I'm done. I just pulled out that factor of 3x, okay? So let's take a look at our last example for real. This one's got 4 terms, right? So when something's got 4 terms, we have another way of handling that one, and this one's going to be really important for the next video when we talk about trinomials with a leading coefficient greater than 1. Right, so what we're looking at here is we're saying, okay, well, my first rule that I learned about was for trinomials with 3 terms. That's not going to apply here. My next possibility was 2 terms. That was difference of squares. That doesn't apply here. This doesn't have anything in common because this first term only has x's and this last one only has numbers, so they don't have any common factors that I can use GCF for. So we need a new method. If we're going to do 4-term polynomials, it's going to be like, well, how do I handle this? So here's the way we do this one. This was called factoring by grouping. So I'm going to group the first 2 elements, x cubed and 3x squared, and I'm just going to look at those 2 and say, do they have anything in common? And they do. They have 2 x's in common. So this one has 3 x's, this one has 2 x's, so they share 2 x's. So I'm going to remove those 2 x's. And it looks like, when I have to rebuild this, I'm going to say, well, x squared, there's 3 of them here, that means I need 1 left there. And then x squared, and I need it to be 3x squared, which means I need a 3 here, right? X squared times 3 would give me back my 3x squared, okay? So now I'm going to do the same thing with this second part. I'm going to say, here's another group. Do they have anything in common? And the answer is yes, they have a 2 in common. So I'm going to say that this has a positive 2 in common, and it looks like, again, I'm going to be left with x plus 3. So if you notice what happened when I pulled away the GCFs, the remainder, the leftover, was the same, x plus 3 in both cases. So in order to factor this, this is grouping, factoring, now we need to regroup. Regrouping means, let's take these x plus 3s that are common, and we're going to write that as one of the factors. X plus 3 is a factor because it's shared between the groups. The other factor is going to come from putting together what you pulled away as a GCF. So x squared plus 2, and so I'm going to write x squared plus 2. This is my completed factoring. And I'm not going to go through this, but if you were to FOIL this out and multiply all this out and combine like terms, you're going to end up with your original expression back. So we have a type of factoring that works for quadratic trinomials, which is 3 terms. We have one that works for difference of squares, which is 2 terms, and now we have one that works anytime we see an expression that has 4 terms. Okay, and then we have the special one, GCF, which can work for anything but might not. We have to actually take a look. Okay, so that's going to be the end of this video. We're going to talk about specifically another type of trinomial factoring in the next video, right? And then we will start with geometry.